first thing is we have from UC Berkeley News, that says new evidence that all stars are born in pairs. Well, that's pretty interesting. So obviously that would beg the question to then what happened to our binary sun Nemesis, right? Where did it go? Well, they have an explanation for that, but they say that basically it requires that for all stars to be born in pairs for a lot of the heliocentric model to work. And let me get down to this. Where was it? Okay, many stars have companions, including our nearest neighbor, Alpha Centauri, a triplet system. Astronomers have long sought an explanation. Are binary and triplet star systems born that way? Did one star capture another? Do binary stars sometimes split up and become single stars? So astronomers have even searched for a companion to our sun, a star dubbed Nemesis, because it was supposed to have kicked an asteroid into Earth's orbit that collided with our planet and exterminated the dinosaurs. It has never been found. So we're saying yes, there probably was a Nemesis a long time ago, said co-author Stephen Stoller at UC Berkeley, research astronomer. We ran a series of statistical models to see if we could account for the relative populations of young single stars and binaries of all separations in the Perseus molecular cloud. And the only model that could reproduce the data was one in which all stars form initially as wide binaries. These systems then either shrink or break apart within 1 million years. And of course, they say in this study, wide means the two stars are separated by more than 500 AU. Which of course in AU is 93 million miles. So again, we're dealing with these astronomical distances, is pretty crazy. So let's see, let me get down to the other part. According to Stoller, astronomers have known for several decades that stars are born inside egg-shaped cocoons called dense cores, which are sprinkled throughout immense clouds of cold molecular hydrogen that are the nurseries for young stars. Of course, mind you guys that this is complete speculation, that we've never actually seen this happening. We see some general examples that they say that's what's happening, but we've never seen this actually happen from start to finish or anything like that. So in other words, this whole article, if you read through it, and I'm missing a part that I really found interesting earlier, I'll keep reading through it and see if I can find it. But this article is so comical because it is so speculative in every single way. They are literally pulling assumption after assumption after assumption, pretty much right out of their butt, with this. And I'm amazed that this stuff gets publicized. Because they treat it like it's absolute fact, and it's nonsense and it's pure speculation. But when it comes from UC Berkeley, it must be true, right?